happens?
The Pascal's principle was first enunciated by the French scientist Blaise Pascal. It was discovered during an experiment with a 10-meter long pole being inserted into a barrel that was filled with water. As the water was poured into the vertical tube, Pascal discovered that the pressure from the water caused the barrel to burst. Pascal's principle states that at a point within a fluid, the pressure at that point is equal in all directions. This has two implications for forces acting at that point. The first one is the force exerted on the point by the fluid is the same in every direction. Second one is the force exerted on anything that is in the contact with the point is the same in every direction. Let us now look at an example involving Pascal's principle. So, determining changes in the pressure exerted by a fluid on its container. A cubic container holds water. The lid of the container can be pushed downward, exerting pressure on the water in the container. Describe how the pressure exerted by the water is changed when the lid is pushed downward. To correctly describe this, the pressure exerted on the base of the cube, its vertical sides, and its lid is increased. The question states that a cubic container holds some water. The lid of the container is pushed down, applying pressure to the top surface of the water. Pascal's principle states that at a point within a fluid, the pressure at that point is equal in all directions. We can consider a force applied at the center of the top surface of the water as shown in this figure. We can clearly see that the top surface of the water at the point where the force acts will transmit the force vertically downward as shown in this figure. According to Pascal's principle, the force on the top surface of the water will also result in a force in all directions in the water from the point where the force acts. The first figure shows some of the directions in which the force is transmitted horizontally. Forces would though act in every direction from the point, both vertically and horizontally. The following figure shows some of the directions in which the force is transmitted both vertically and horizontally. We can see from this that there must be a force acting on each side of the container. This tells us that there will be an increase in pressure on each side of the container. This includes the lid, as the top surface of the water will exert a force upward on the lid. Therefore, the pressure exerted on the base of the cube, its vertical sides, and its lid is increased. Pascal's principle means that a force can be transmitted through a fluid and change direction as it is transmitted. Did you know? A vertically downward force can act on the horizontal surface of a fluid at one end of a pipe. The force applies pressure throughout the fluid. As a result of this applied pressure, a vertically upward force acts on the surface of the fluid at the other end of the pipe. It is important to notice that the ends of each pipe are at the same height. For each pipe, the areas of the ends of the pipe are equal. For the curved pipe, the area of the pipe is constant along the length of the pipe. For the straight pipe, the cross-sectional area of the pipe is greater where the pipe turns. For both pipes, only the areas of the ends of the pipes need to be considered. For each pipe, the magnitudes of the forces at the ends of the pipe can be related by the formula pressure is equal to force 1 over area 1 or force 2 over area 2. For each pipe, the areas of the ends of the pipe are equal, hence, it must be true that area 1 is equal to area 2. we see that the magnitude of the force applied to the fluid at the left-hand end of the pipe is equal to the magnitude of the force applied by the fluid at the right-hand end of the pipe. Therefore, force 1 is equal to force 2. A pipe need not have ends of equal areas. If the areas of the ends of a pipe are not equal, then the forces acting will not be equal as well. We can apply the equations to a pipe within which the pressure is the same at both ends, which is the pressure is equal to force over 1 over area 1 or force 2 over area 2. From this, we can see a relationship between the areas of the ends of a pipe and the forces acting on those areas. So for the relationship, the forces on the ends of a pipe and the cross-sectional areas of the ends of the pipe. For a pipe that has equal pressure at its ends, the magnitudes of the forces acting at the ends are related to the cross-sectional areas of the ends by the equation, where F1 and F2 are the magnitudes of the forces acting on the ends of the pipe, and A1 and A2 are the cross-sectional areas of the ends of the pipe. Determining the force exerted on an area of a fluid due to a force acting on a different area of the fluid. A hydraulic pump has a thin shaft with an area of 0.15 square meters and a thick shaft with an area of 1.2 square meters as shown in the diagram. At the tops of the shafts are pistons that can be pushed. A force of 85 Newton is applied to the piston in the thin shaft, and the pressure of the hydraulic fluid applies a force to the piston in the thick shaft. Find the magnitude of the force 2. In answering this question, we recall that the pressure on the base of the pistons due to the pressure from the enclosed fluid is equal. This means that for the base of each piston, it is the case that pressure is equal to force over area, where F is the magnitude of the force acting on the base of the piston and A is the cross-sectional area of the piston. Each piston has a different force acting on it on a different cross-sectional area. We can relate the forces on and cross-sectional areas of the small and large pistons with the equation force 1 over 0.15 square meters is equal to force 2 over 1.2 square meters. The question asks for the magnitude of force 2, so we must make force 2 the subject of the equation as follows. The question states that force 1 is equal to 85 Newton. We substitute this value to obtain F1 times 8 Newton is equal to F2. So by substituting, we could have 85 Newton times 8 Newton, that would be 680 Newton. So our force 2 is equal to 680 Newtons. We see from the example that by applying a force of 85 Newton to one piston, a force of 680 Newton was exerted on the other piston. Pascal's principle means that a force can be applied to a small area in order to exert a greater force on a greater area. A machine that uses Pascal's principle to multiply a force in this way is called a hydraulic press. The ratio of the force exerted on the piston of a hydraulic press with a lesser area to the force exerted by the piston with the greater area is the mechanical advantage of the hydraulic lever. The mechanical advantage of a hydraulic press is equal to the ratio of the areas of the pistons. For the hydraulic press in this example, it is 8. To summarize everything, Pascal's principle states that a point with a fluid, the pressure at that point is equal in all directions.